In the previous video, we have managed to add a line and a triangle on mouse down. So if I press my mouse down over here, as you can see, I have the triangle and there is also a line added, okay? But because since this is a mouse down event, all right, the line is actually a point, okay? So in this part, we'll be learning how to extend out the line and make sure that this triangle over here moves to the same position as the cursor. All right, so let's get started. So what we want to do is this start drawing of the single arrow line over here. So it's almost the same as start drawing line. So we can copy some of the code from the start drawing line function. In fact, we can copy all of this. All right, so let's copy all of this and we can add it over here. Okay, so now over here, what it says is if mouse down is true, all right, and the pointer will help us get the coordinates of the cursor. So the line will be set to x2 and y2, all right, and these are the coordinates, okay, the new coordinates of x2 and y2, all right, and we also need to make sure that the arrowhead follows the cursor as well, okay, so this is something different. All right, so the arrowhead, we gave it a variable of arrowhead 1 and we have to set this as well. Now, since the arrowhead is actually a polygon, okay, so there's no x2 and y2. Instead, we can just, we need to put the left position. All right, so the left position would be pointer dot x and the top position would be pointer dot y. All right, so over here the line and the arrowhead will be set to wherever I move the cursor. All right, so let's just see what happens over here. Let me click this and let's move this. All right, as you can see, okay, the line extends to wherever the cursor is and the arrowhead follows the cursor, okay, but you realize something over here that the arrowhead, okay, does not tilt to the correct angle, okay, it's always at the fixed angle. All right, so we actually have to rectify this, okay, we have to change the angle of the arrowhead. All right, so let's try to rectify this, and before we do some coding, I have to explain a few things, okay, on how to rectify it. So we can actually split up the screen to 4 quadrants over here about the starting point of the arrow line. All right, and let's say my line, okay, starts from this this starting point over here and it moves to the right, okay, so it doesn't slope up or down, okay, it just moves horizontally to the right, okay, and let me change this color over here to something else. All right, so okay, so let's have another arrow line and it tilts over here and another arrow line and it tilts like this. All right, so now when the arrow line, okay, is resting on the x-axis over here, the angle, all right, the angle of this triangle over here, okay, the angle of this triangle is equals to 0 degrees. All right, now for fabric, okay, when it goes up, okay, the angle is not positive, okay, so like let's say for this it will be negative, let's say for instance negative 30 degrees. All right, so when it goes up is negative 30 degrees and the angle for the triangle must be negative 30 degrees over here. All right, so that the triangle would have would be pointing in the correct direction. All right. And let's say for this, let's say this is 40 degrees over here. Okay, so if it goes down, all right, if it goes down, the angle is positive. So the angle of the triangle must be positive 40 degrees. All right. So we actually have to find the angle, okay, of how much the line is sloping upwards or sloping downwards. Okay, so how do we find the angle? Well, what we can do is to use trigonometry. Okay, so we actually have to find the vertical height and the horizontal width over here. Okay, and we know that this point over here, the coordinates are x2, y2, and this point over here, the coordinates are x1, y1. So in order to find the vertical height, it's just y2 minus y1. All right. And the vertical width is x2 minus x1. So using these two, all right, so let me draw a right-angled triangle here. So we have y2 minus y1 over here, x2 minus x1 over here. And this is a right-angled triangle. So this is theta. So with respect to this angle, okay, this side is the opposite side. Okay, the opposite side. And this side is the adjacent side. All right. So we have to use trigonometry. Okay, so since we only know the opposite side, the length, and the adjacent side, the length, all right, we have to use tangent. Okay, so it means tangent of this angle must be equals to y2 minus y1 divided by x2 minus x1. Okay, so hopefully, all right, you have paid attention in your math class. All right, so tangent theta is equals to this. Okay, so in order to find the angle theta, all right, it will just be the inverse tangent of this whole value, y2 minus y1 over x2 minus x1. Okay, so this is how we can find the angles. All right, so let's do that. Okay, so it's a little bit quite daunting. Okay, let's just try to do it. So the first thing what we need to do is to find the vertical height and the horizontal heights. All right, so we know the line. Okay, we know the x2 and the y2 is just the pointer dot s and pointer dot y. But what about the x1 and y1 coordinates? So meaning this over here. Okay, how do we find the x1 and y1 coordinates? Well, it's actually quite simple. All right, what we can do is to say let x1 equals to line dot x1. All right, because the line has an x1 coordinate. Okay, so initially when we press our mouse down, okay, that is the x1 coordinate for the line. All right, and same thing for the y1. Let y1 equals to line dot y1, and let x2 equals to line. Okay, for this case, it will be pointer dot s. No more line, all right, because the s1 and y1, they are fixed. All right, so it doesn't change, but the s2 coordinate changes according to where the cursor is. All right, so same thing for the y2. Let y2 equals to pointer dot y. All right, so now we have this. We have to find the vertical height and the horizontal width. So we can say let vertical height be equals to, so I want it to be an absolute figure. Okay, meaning I do not want it to be a negative value, because when we take y2 minus y1, all right, y2 can be smaller than y1 and we have a negative value. Okay, but I just want it to be positive. And we do the same for the horizontal. Let horizontal width be equals to math dot absolute x2 minus x1. All right. So the vertical height and the horizontal width, okay, it changes whenever I move the mouse. All right. So over here, the next thing we have to do is to find the, all right, the value of y2 minus y1 divided by x2 minus x1. So it means the ratio of this tangent of this angle. All right. So what we can say is, let the tangent ratio be equals to the vertical height divided by the horizontal width. Okay, so now in order to find the angle itself, so okay, for this angle, since I made the vertical height and horizontal width always positive over here, okay, the angle would be always positive. All right, and it will always be an acute angle. Acute angle meaning it would be from 0, okay, from 0, well, between 0 and 90 degrees. Okay, so that is an acute angle. All right, and the angle will always be positive. Okay, so we do not have this negative 30 degrees. All right, so I call this basic angle. All right, let this basic angle be equals to, so I have to find out how do we find the inverse tangent. Okay, let's do some Googling. Okay, how do we find inverse tangent JavaScript? Okay, so it's A10. Okay, A10 over here. So let's do that. All right, so wait, let me check again whether this is correct. Let's say math.a10. All right, math.a10. Okay, so math.a10. Okay, and it would be the tangent ratio. Okay, so if we go to our board over here, all right, so tangent ratio is this. Okay, so this is tangent ratio. Now, if I just want to find the angle, I have to find inverse tangent of this value. All right, so is in our code is actually math.a10 of this value. Okay. All right, so we have this basic angle over here. Okay, and let's just console.log this basic angle first. Basic angle. Okay, so let's go over here, open up our console. Okay, I add this, and as you can see, our basic angle, okay, is in the radian. All right, is in the radian format. Okay, so for Fabric, okay, it uses the degree format. Okay, but our basic angle over here is in the radian format, so we actually have to convert it into degrees. So let's do that. Okay, so for this, all right, what we have to do, since we have to convert it into degrees, so let me explain it over here, how to convert from radians to degrees. So we know that pi radians is equals to 180 degrees. All right, so if I have 1 radian, I will have 180 degrees divided by pi over here. Okay, so now if I have whatever value, okay, that let's say theta radian over here, it means I have to times theta. All right, so it is 180 degrees over pi times the angle. Okay, so what we have to do over here, all right, so this is the angle in radians. All right, so we have to times this by 180 degrees. Okay, so times 180, and then we have to divide by pi. So math.pi. All right, so let's console log this and see whether now it is in degrees. Alright, as you can see, now it is in degrees. Okay, so let's say this is 18 degrees. Okay, if I go up, I'm reaching 90 degrees over here. Okay, I'm going to, as you can see, the range is from 0 to 90 degrees. Okay, it doesn't go beyond 90 degrees. Alright. Okay, so I think all is good over here. We have found the basic angle. We can use this basic angle to adjust our triangle. Alright, so I'm going to do the first quadrant. Alright, the first quadrant would be this part over here. Alright, this part is the first quadrant. So it's actually a negative angle over here. So the triangle, alright, must have an angle that is negative. Okay, if I move up. Alright, so let's do that. So what we have to do, okay, we can actually cut this out and paste it down over here. Okay, and the angle, alright, the angle must be negative of the, negative of the basic angle. Alright, now this only occurs in the first quadrant, so we actually have to add some conditions. Alright, and the condition is when the arrow line is in the first quadrant, okay, the x2 is bigger than x1. Alright, and the y2 value is smaller than y1. Okay, so take note. Alright, as we go up higher, okay, the value of y would be smaller, okay, than if it's lower. Alright, so this is how the measurement is, alright, for online website like this. Alright, so y2 is actually smaller than y1. Okay, so x2 is bigger than x1. So we have to give a condition if x2 is bigger than x1. Alright, and over here is we say if y2 is smaller than y1. Okay, so the arrowhead would have this angle over here. Alright, so there are actually another condition, well, another condition that the line can be at. Okay, so not only the line can be the first quadrant, so if I move the line down, okay, the y2 now would be the same as y1. Alright, this blue line over here. And then if I move further down, the y2 would be greater than y1. So there are actually two more conditions. Okay, so or else if y2 is equals to y1, okay, we have something else. Alright, we have to convert this. Alright, and or else if, okay, y2 is greater than y1. Okay, so we have something else over here. Alright, I realized that we actually do not need to always copy and paste this left and top position to these two, inside these two conditions. Alright, we can just do it once. Alright, so what I mean is, okay, we can set the arrowhead positions over here. Alright, and this we just set the angle. Okay, so the arrowhead one, alright, when it's in the first quadrant, the angle is a negative basic angle. Now when it's equals to one another, y2 is equals to y1, so it means the blue line over here. As you can see, the angle must be 0 degrees. Alright, so we can say the angle here should be 0. Okay, now what about y2 greater than y1? So this line over here, alright, the angle is positive. Okay, so it would just be, the arrowhead here would just be positive. Okay, so let's check for this first and the last quadrant. Okay, so this is first quadrant, this is second quadrant, third quadrant, and the fourth quadrant. All right, so let's just check the first and the fourth quadrant. All right, this right side. Okay, so over here, so I have the line, as you can see, is tilted. The arrow is tilted correctly. Okay, so over here is tilted correctly as well. All right, so everything is well on the right side, but we haven't done nothing to the left side. So if I move to the left, as you can see, all right, there's something wrong. Okay, it's not pointing in the correct orientation. All right, so we have to do something on the left side as well. Okay, so let's do that. So on the left side, okay, x2 is lesser than x1. All right, x2 is lesser than x1. So we can say else if x2 is lesser than x1. All right, so we have all these three conditions again. Okay, so let's say if y2 is more than y1 first. All right, if y2 is greater than y1. Okay, what do we have? So this means that the line would be in this quadrant over here. All right, so over here y2 is more than the original position here over here. All right, is more than y1. Okay, so I can write it down over here. This is x2, y2. All right, so y2 is more than y1 and s2 is less than s1. Okay, so now when it's over here, all right, the basic angle is this. All right, this is the basic angle. Let's call this alpha over here. Okay, so we actually have to find this angle over here. We have to put this value in our code. So it's just 180 degrees minus the basic angle. All right, so this over here, it would be 180 degrees. 180 degrees minus the basic angle. Okay, then next, else if, all right, y2 is equals to y1. Okay, so the arrowhead, all right, or rather the arrow would be pointing this way. Okay, it will be pointing this way. All right, let's change this color to blue, stroke blue as well. So it will be pointing towards the left. Okay, so over here, all right, the angle is not 0 degrees. Okay, it's not 0 degrees. The angle over here is 270 degrees. Okay, because sorry, not 270, it's 180 degrees. All right, it's because we find the starting position starts from here and we go to here. All right, so this angle is 180 degrees. Okay, so if y2 equals to y1, it is just 180 degrees. All right, and we have another condition, else if y2 is less than y1. Okay, so now the condition, all right, so let's go back here. So I can have an arrow that is pointing in the second quadrant over here. All right, so the basic angle is this, sorry, this part. Okay, this is the basic angle now. So it is 180 degrees over here plus the basic angle. Okay, 180 degrees plus this basic angle. And then we can have our arrow pointing in the correct orientation. All right, so 180 degrees, then plus this basic angle. All right, so we have all of this over here. Okay, and what we need to do also is to set the coordinates for the line and the arrowhead. 1. All right, so let's set the coordinates. So the line dot set coordinates for this, and the arrow head 1 dot set coordinates, coords. All right, so we have to do this so that Fabric knows where exactly the line and the arrowhead are. All right, so now let's try it over here. So I click on this. So I have the arrow line. Okay, so seems all right now. Okay, so the arrow head is pointing correctly. All right, so as you can see, it's pointing in the correct orientation, at the correct angle. Okay, so in the next video, we'll be talking about how to do the mouse up function. Okay, because now when I stop pressing my mouse, okay, I'm still drawing, okay, the arrow. All right, the arrow line. Okay, so I'll see you in the next video.